Alright, today we're doing Chapter 4, Section 2, Solutions of Two Variable Equations. And while you copy that down, I'm just going to make a couple comments. This kind of goes back to 4.1, the last section where we were talking about how a lot of situations in life have two variables. And now we're just looking at how to solve those. It's really kind of a small extension of what we were doing yesterday. And yesterday we were taking x values, putting them in the equation, finding y values, and using that to fill in a data table. We're going to be doing similar sort of things today. But if you look at those points we put in the data table, we had an x value, we found a y value. Well, if you take those and put those together, that gives you an ordered pair. And an ordered pair, usually they write them this way, that they'll always write the x value, the number for x first, the y value, the number for y second. But that's going to be what the solution looks like. The solution really is just a point. It's an x value and a y value that both fit in that equation together. So really this section, we're going to be finding points. We're going to be finding x and y values that work for an equation. So Roman numeral 1, finding a solution. And this looks a little bit different than 4.1 because we're not using this with a data table, but essentially it's that exact same concept. So I'm going to put a little star, and for that usually we have an equation something like this. I'm going to jump ahead to my example, and my example equation is going to be y equals 3x minus 4. In this example, it would be a whole lot easier to put a number in for x, then you just multiply by 3 and subtract 4 and you have your y value. So it's going to be a lot easier to put in an x and find a y value than to know what y is and have to work backwards to add 4 to both sides, divide both sides by 3, so to find x. So to find a solution, I'm going to write put in x, comma, find y. The reason it's a whole lot easier is equations are typically written as a dependent variable, the y value, by itself. So x is in the middle of a whole bunch of numbers, so it's a lot easier to find y if you know what x is. Let's do this first example. I'm going to say find two solutions for, then we have the equation there, y equals 3x minus 4. And with these, there's an infinite number of solutions we could come up with, but remember, we're just trying to find points. We're trying to find an x value and y value. The difference is we don't have a data table like we did in 4.1. So at this point, you just pick an x value, and I'm maybe going to pick an x value of 1. So if my x value is 1, I could just put it right in there for x. So I have a 3 times 1 minus 4. We have to multiply first, so I get a 3 minus 4. So my y value then has to be a negative 1. And we could do that exact same thing, but just with a different x value. So maybe a different person for their point might pick like a 7. And then it would be 3 times 7. Take away 4. Well, that's 21 minus 4, so we get 17. And, somebody else might pick two different points. And sometimes the questions will say, find the solutions when x equals 0, x equals 1, x equals 2, and so on. But if you just need to find a solution, you really could pick any number for x and find y. The second part, and sometimes you'll get questions that ask you to do this, they say, well, check something. Check, is this a solution? So, and other times, maybe you'll just want to check your own work and say, okay, am I right? So Roman numeral 2 is checking a solution. So checking a solution. I'm going to put the little asterisk and kind of say what to do first. Substitute x and y values in, see if it's equal. So substitute in x and y. So this would be where you know the point, and see if it's equal. And maybe you'd see a question that says something like, is the point 5, 8, so I'm going to do it, is 5, comma 8, a solution to y equals 2, then in parentheses x minus 1. So it could be that you just found 5, 8 as a solution, you want to check it. It could be that someone's asking you to check it. Well, for that, what messes up some people is these points. The x value is always listed first. So right here, the 5 has to be my x value. The 8 has to be the y value. Now, in an equation, usually equations are solved for y, so y is listed first. So a real common mistake is that people will take the 5, put it in for the first variable, take the 8, put it in for the second variable, and say, nope, it doesn't work. But you have to remember that this 5, since that's the x value, it has to go in right here. And since the y is 8, that goes in right there. And now I could fill in the rest of my numbers. We're really just trying to see, are those two sides of the equation equal? What the book will often do is they'll actually put like a little question mark above the equal sign. Then they'll copy everything down each line. And find some way to show that you're checking your work if you do something like this. You don't have to do it the same way as the book where they put in like the little equal sign every time with a question mark over it. Then we have 8 over here. The other side we have 8. So we could do a check. Yep, those two there are equal. The last thing I want to do, Roman numeral 3, is going to be solving story problems, or I'll just write story problems. And you don't have to actually write out this whole story problem, so I wouldn't work ahead and try to quick do that. I really just wanted to show kind of how I go through and try to pull numbers out of a story problem. But the key to doing those is, first of all, write the equation. So I broke it up into 2 steps. I actually asked you to write an equation for step A. But if they even don't ask you to do that, it's sometimes smart to go through and say, all right, what's just kind of the general equation before I put numbers in? And then after that, you put in number and solve. So put in numbers. Maybe I'll say numbers and solve. Because sometimes you're going to have more than one number you need to put in your equation depending on the variables and such. So here's my example. And like I said, I wouldn't go through and write all this down if I were you. So Jen works as an exterminator. She charges $15 per house call. So sometimes I'll go through and kind of underline stuff on a test or quiz at least. So $15 per house call, that's going to be part of my problem. And $6 for each critter she catches. Write an equation for the bill based on the number of critters she catches at a house. So most of our equations are going to be like x equals something or y equals something. Here we have different letters, but we are going to have a single variable equals something. And when they go through and say, all right, write an equation for the bill based on the number of critters, you know that the b, the bill, is going to be the dependent value, that it's going to be by itself. So I'm going to write b equals just for starting point. And then the bill, how much she charges, depends on the number of animals she catches. So my c value is the independent. It's going to be over here on the right-hand side of the equation. Now, one of those two numbers typically is going to be paired up with c. So the number of critters she catches is going to be related to either the $15 or the 6. Well, the 15 is the cost per house call. The 6 is $6 for each critter. So the 6 is going to be somehow related to the c. And then you just have to figure out, is it 6 plus c, 6 minus c, 6 times c? Well, if she catches one critter, it costs her $6. So you're looking at, okay, so 6 and 1. It's looking like multiplication because that would give me 6. If she catches 2 critters, a lot of people can see, okay, it's going to cost $12 then just for that part of the bill. So it has to be a 6 times 2 to give me 12. So B equals 6C, and then the $15 as well, that and might tell you. Or you could say, well, it's going to cost $15 just to come to the house, plus, then she has her charge depending on how many animals she catches. So long story short, our equation is B equals 6C plus 15. And once we're there, now we just say, all right, what's the bill if she catches 5 raccoons at your house? So 5 is going to be the number of critters she catches. So we end up getting B equals 6 times 5 plus 15. And you do order of operations, you have to multiply first, so I get $30 plus 15. So the total charge then is going to be $45 for Jen to come and take care of your raccoon problem. That's all for section 2.